Today's lesson is going to be lesson 6.3. It's called Proving that a Quadrilateral is a Parallelogram. And our objective today is going to be to determine whether a quadrilateral is a parallelogram. Remember in 6.2, we knew that we had a parallelogram, and then we had some properties about parallelograms. Today, what we're going to do is we're going to use those properties to try and show something is a parallelogram. So today is converse day. We're going to take a lot of the theorems that we did in 6.2, and we're going to look at the converse of those theorems as it applies to proving quadrilaterals are parallelograms. So let's remember theorem 6.3 from the other day. If a quadrilateral is a parallelogram, then we said its opposite sides were congruent. That was theorem 6.3. What we're going to do today is we're going to look at the converse of that theorem. Remember, the converse says take your hypothesis and your conclusion, and we're just going to switch them. And when we switch them, we get theorem 6.8. And theorem 6.8 says that if both pairs of opposite sides of a quadrilateral, that should be quadrilateral, let's take that I out of there, are congruent, then the figure is a parallelogram. We just kind of switched the hypothesis and the conclusion, but we added one little thing. And that is if both pairs of opposite sides, that's really important. Both pairs of opposite sides have to be congruent, then the figure is a parallelogram. So in a diagram, if we have a quadrilateral, if we know that both pairs of opposite sides are congruent, then this figure must be a parallelogram. And I'm going to say it again. In 6.2, we knew they were parallelograms. We then said some things about them. This is converse day. Here we know some things about the figure. We're going to then conclude it has to be a parallelogram. Okay, back to 6.2 now. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So in section 6.2, we knew we had a parallelogram. We then concluded its consecutive angles were supplementary. In 6.3 now, we have a figure. Its consecutive angles are supplementary. Therefore, it must be a parallelogram. And that is theorem 6.9. And 6.9 reads this way. We have to tweak it a little bit. If an angle of a quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. Let's take a look at that in a picture. So in this picture, we have a four-sided figure. It's a quadrilateral. We don't know if it's a parallelogram yet, but theorem 6.9 says if an angle of a quadrilateral, this one, if an angle of a quadrilateral is supplementary to both of its consecutive angles. So 70 is supplementary to that consecutive angle because they add to 180. And it's also supplementary to this consecutive angle because they add to 180. Then this quadrilateral must be a parallelogram. Okay, so 6.9 is saying we pick one angle. If it's supplementary to its two consecutive angles, then it's a parallelogram. Theorem 6.5 from the other day said if a quadrilateral is a parallelogram, then its opposite angles are congruent. Theorem 6.10 says that if both pairs of opposite angles are congruent, then it's a parallelogram. So we're going to basically take our hypothesis and our conclusion, and we're going to swap them to get theorem 6.10. If both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. Let's see a picture of this one. So we've got a four-sided figure. If we know that this angle is congruent to this one, the opposite angles are equal, and these two opposite angles are equal, then theorem 6.10 says you got a parallelogram. So if both pairs of opposite angles happen to be congruent to each other, then we have a parallelogram. Theorem 6.6 came from the previous section. If a quadrilateral is a parallelogram, then its diagonals bisect each other. They cut each other in half. Well, theorem 6.11 is just going to be the converse of this one. We're going to take diagonals bisect each other, and quadrilateral is a parallelogram, and we're going to flip them to get theorem 611. If the diagonals bisect each other, then that four-sided figure must be a parallelogram. So if we have this four-sided figure and we draw in the diagonals, make sure I have a pen. If I draw in the diagonals, there's one. Let's draw in the second one here. If those diagonals bisect each other, so this one gets cut in half and this one gets cut in half, then the figure has to be a parallelogram. That's theorem 611. Now, theorem 612 is kind of a standalone. It's not the converse of a theorem from section 6.2. It says if one pair of opposite sides is both congruent and parallel, then the figure is a parallelogram. So we've got one pair of opposite sides being both congruent and parallel. So if these sides were marked congruent and they're marked parallel, that's enough for us to say that the figure is a parallelogram. Now this one's a little different. In the others, you had both pairs of opposite sides being congruent, both pairs of opposite angles being congruent. Now this one's a touch different in that one pair of opposite sides is both congruent and parallel. So that's a little different check for us. So what we can do is we can organize these six ways to show that a quadrilateral is a parallelogram. So I organized them into kind of a summary here. One, we can prove that both pairs of opposite sides are parallel. If we do that, we're using the definition of a parallelogram and the picture out here to the right to illustrate that, where we have both pairs of opposite sides being parallel. So that picture right there. The second way is to prove that both pairs of opposite sides are congruent. If we use that, we use theorem 6.8, and you can see the diagram where I have both pairs of opposite sides marked congruent. The third way is to prove that an angle is supplementary to both of its consecutive angles. That's theorem 6.9. And in the picture, I've got an angle marked at 75 degrees, showing that it's supplementary to both of its consecutive angles. The fourth way is to prove that both pairs of opposite angles are congruent. That's theorem 6.10. You can see how I have that marked in the diagram. The fifth way is to prove that the diagonals bisect each other. And so in the picture, I have the two diagonals, this one getting cut in half. These both have one hash mark. And this diagonal getting cut in half. They both have two. And then finally, to prove that one pair of sides is both congruent and parallel. So in the picture, I've got the hash marks to show that the two sides are congruent. And I also have the arrows to show that the two sides are parallel. So it's one pair of sides that are both congruent and parallel. So if you're going to put anything in your notes, this would be a good thing to put in your notes. There's also a picture of it in your book on page 371. Okay, let's go through some example problems that you're going to see on your homework. The first one is finding values for parallelograms.
Problem. You will find values necessary for quadrilaterals to be parallelograms. For what value of y must quadrilateral PQRS be a parallelogram? Which theorem should you use? The diagram gives you information about the sides. So use theorem 6.8 because it uses sides to conclude that a quadrilateral is a parallelogram.
So in this problem, we're trying to find out what the values are for x, and the problem asks for y, but we're going to have to find both that make this a parallelogram. For it to be a parallelogram, the opposite sides have to be equal, and then we can use theorem 6.8.
Step 1. Find x. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So, for PQRS to be a parallelogram, the length of segment PQ must equal the length of segment SR. Subtract 2 times x from each side. Now add 5 to each side. So x equals 6. Step 2. Find y. Again, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So, for PQRS to be a parallelogram, the length of segment QR must equal the length of segment PS. Substitute 6 for x. Simplify to find y. So in order for figure PQRS to be a parallelogram, the value of y must be 8.
Okay, we're going to look at another example where we're trying to decide whether the figure is a parallelogram.
In this problem, you will decide whether a quadrilateral is a parallelogram. Can you prove that the quadrilateral is a parallelogram based on the given information? Explain. Part A. You are given that the length of segment AB is 5, and the length of segment CD is 5. You are also given that the degree measure of angle A is 50, and the degree measure of angle D is 130. Can you prove that figure ABCD is a parallelogram?
Well, let's look at what we know. We know we have one pair of opposite sides, AB and DC, that are equal. If we could show that AD and BC were equal, then we could use theorem 6.8, that the opposite or both pairs of opposite sides are congruent. But we don't know anything about these sides. So we're going to have to use something about the angles in this problem.
How do you decide if you have enough information? If you can satisfy every condition of a theorem about parallelograms, then you have enough information for a proof. The sum of the measure of angle A and the measure of angle D is 180. That means same side interior angles A and D are supplementary. So segment AB is parallel to segment CD. Since segment AB is congruent to segment CD, and you also just proved that they are parallel, figure ABCD is a parallelogram by theorem 6.12. So yes, you can prove that ABCD is a parallelogram with the information given.
Okay, and we'll stop there and not do the rest of the problem because we have shown that ABCD is a parallelogram. We've shown that one pair of opposite sides is both congruent, they're both 5, and parallel, because 50 and 130 are same side interior angles, making AB parallel to DC. Okay, this next problem is kind of an application problem. You're going to have one kind of like it in your Math Excel homework. So I'm going to let this one just kind of play as it goes through how to identify parallelograms.
In this problem, you will identify parallelograms. A truck sits on the platform of a vehicle lift. Two moving arms raise the platform until a mechanic can fit underneath. Why will the truck always remain parallel to the ground as it is lifted? Explain. As the arms of the lift move, what changes and what stays the same? The angles the arms form with the ground and the platform change. But the lengths of the arms and the platform stay the same. The angles of figure PQRS change as the platform, segment QR, rises. But its side lengths remain the same. both pairs of opposite sides are congruent. So figure PQRS is a parallelogram by theorem 6-8. By the definition of a parallelogram, segment PQ is parallel to segment RS. Since the base of the lift, segment PS, lies along the ground, the platform, segment QR, and therefore the truck will always be parallel to the ground.
Okay, so that's lesson 6.3, proving that a quadrilateral is a parallelogram. And our objective was to determine whether a quadrilateral is a parallelogram. And remember, we had 6 ways to do that. And those 6 ways are given in this summary. And again, if you don't have this in your notes yet, I would encourage you to put it into your notes because there are only 6 ways to do it, and these are the only 6 that we have. The definition of a parallelogram and theorem 6.8 through theorem 6.12.